if plotted with graph, we are told that we should plot the ordering cost against ordering quantity. So here becomes our what? Our cost, and here becomes our what? Ordering what? Quantity. So in this case, in the graph, we are going to have here as our what? Ordering cost. We have here as the what? The holding cost. And here will be the total variable cost. So the question says, from your graph, we should determine Roman figure 1, the economic order quantity. Now the economic ordering quantity, EOQ is given as the square root of 2DCO over CH. So EOQ, which is also known as simply Q, we have D. D here is what? Is 2000. We have CO to be 1250 and CH to be equal to what? 20. So you impute, you have 2 times 2000 times 1250 over what? 20. So you have EOQ to be equal to 500. Then question 2 says the total minimum variable cost. The total minimum variable cost, from your table, you see that what? Total minimum variable cost is given total minimum variable cost is given as what? As the fine. We are voting our what? EOQ to be 500. So from your table, you can able to trace the what? The total minimum variable cost, which is 5,000, the total ordering cost, plus the total holding cost, which is 5,000 plus 5,000, which will give us what? 10,000. Then we are asked the ordering frequency that produces the EOQ. So the ordering frequency that produces the EOQ, from your table and also from your graph, you will see that what? The EOQ is when the total ordering cost is equal to the what? The total ordering cost. And the ordering frequency at that place is what? Is 4. So the Roman figure 3, the ordering frequency that produces the EOQ is equal to what? 4. Why are random numbers important in simulation? Random numbers are important in simulation. Random numbers are important in simulation because they help in choosing random samples, or you can call it observation. from the probability distribution. Now, they now ask us to mention 5 ways that they can be what? Generated. What are the ways in which we can generate random numbers? What are the ways in which we can generate random numbers? Since we now know why random numbers are important in simulation, now we have to look at why are the ways in which we can generate random numbers. The first one is the arithmetic computation method. Then the second one is the computer generator method. Now, we also, this computer generator method, it has to do with what? You using your computer system, using MS Access to generate random numbers of your choice. Then the arithmetic computation method is adding 2 separate random numbers, integers, to get the random number that you need to carry out the simulation. Then the third one is the physical tools method. Now, the physical tools method, e.g., dice and coin, etc. Now, this physical tools method is, based on what you have been taught earlier on. Dice, we have, in 2 dice, we have 2 faces. A die has 6 numbers, and if it is 2 dice, if it is now dice, we have 6 by 6, which is 36 in total. And if you should roll those dice, there is a probability of you getting 1 1, 1 2, 2 1, and so on and so forth, which is also a way of getting random numbers. Another way is another physical tools method is by you using a coin. Flipping of a coin is in 2 ways. When you flip the coin, it's either it gives you head or tail. And in simulation, we can also be given a coin. We ask to flip a coin to generate random numbers. And by the time we flip that coin, we are going to get either a head or a tail. So you can have your probability, you can have head, tail, head and tail, and so on and so forth. Then the fourth one is random timber table. This is arranging your timbers in a random format, placing it on a table and using it to generate your random number. By the time you log it, then you're able to say, okay, this is 5 timbers. Let me place them on this table. So that 5 timbers will give you 5 as a number. Then, and so on and so forth, you generate random number from there. Then the 5th one is you using probability distributions.